This is the third video looking at critical reasoning. If you've seen the video on inductive reasoning and deductive reasoning, then this video on abductive reasoning will follow a familiar structure. We'll look at some definitions, some key characteristics, and then move on looking at the common criticisms and finishing with the counter-arguments presenting the strengths of this particular style of reasoning. Abductive reasoning is the process of looking at an incomplete set of observations and drawing the most likely possible explanation for what you see. Therefore, abduction is sometimes called the inference to the best explanation. This is very different from the deductive process in that the conclusions don't logically follow from the premises. We have to do some abstract thinking to understand how this incomplete set of evidence can lead us to the most likely conclusion. That might sound similar to what we've seen in induction, but abduction does differ from induction in that reasoning involves forming a plausible hypothesis based on incomplete and possibly not directly related information. And that's the key difference here. Inductive reasoning involves drawing general conclusions from specific observations or data. And so there's a much stronger relationship between the information and the conclusion that's drawn. The characteristics of abductive reasoning are that we're looking at starting with observations and seeking the simplest and most likely explanation. And that's a really important feature in nearly all of the reasoning processes that you might read around, that the simplest explanation is often the best. Therefore, as mentioned previously, abductive reasoning is sometimes referred to as inference to the best explanation. The conclusions drawn from abductive reasoning are plausible and probable, but not certain. This means that while the explanation is likely, it's not guaranteed to be true. And the fact that we're including this word plausible is a strong distinction from what we've seen in inductive reasoning. Abductive reasoning is also exploratory and often used to generate hypotheses. It helps in forming initial theories that can later be tested through deductive or inductive reasoning, depending on how much evidence that we find as we work through the process, the research project, the background reading, the gathering of information to help us work towards firmer conclusions. There are different types of abductive reasoning. One of the most common references or examples that you'll see is the diagnostic reasoning, which is used in fields like medicine and engineering to diagnose problems on observed symptoms or malfunctions. For example, a patient might come in with a series of symptoms, and then the doctor might infer which condition that patient has. It's also used in hypothesis generation. So in scientific research, there might be some observed phenomena, and if we don't know exactly what that is, if we haven't seen it before, so we can't apply inductive reasoning, and we haven't seen a certain pattern where an outcome only occurs one way, so we can't apply deductive, we have to make a best guess to generate a hypothesis to explain it, and so we need abductive reasoning to do that. There are other fields when we might need creative problem solving to come up with some form of innovative solution to problems. So for example, a researcher completing community research, liaising with members of the public who frequently mention that there is a lack of public spaces. There could be a hypothesis that this is a key factor in dissatisfaction, and that can progress towards studies that confirm that there is a need for more parks, more public spaces become available to meet the needs that have been raised in the actual research. There are, of course, criticisms of abductive reasoning, one of which is that abductive reasoning does not provide certainty. It offers plausible explanations, though in itself that's a subjective outcome, and that can mean there can be multiple competing hypotheses that need further testing. The process of selecting the best explanation can absolutely be influenced by personal biases and subjective judgments, and those are linked to the level of background knowledge that people have. Abductive reasoning relies heavily on the reasoner's background knowledge and experience, which can limit its applicability in unfamiliar situations. This can also feed into the biases that I mentioned a moment ago by creating a certain mindset, maybe a blinkered vision that makes people unwilling to accept different ideas or different competing hypotheses. There are, of course, counter-arguments. There is a practical utility. Despite being uncertain, abductive reasoning is highly useful because it allows for quick and reasonable decision making in complex or uncertain situations. We can't become paralysed in the unfamiliar because there isn't a way to apply deductive reasoning. And if we haven't seen enough of this particular situation before we can't apply inductive reasoning, that doesn't mean we can't do anything. We need a tool to help us in those situations, and this is where abductive reasoning is particularly strong. We also need to accept that conclusions aren't a stopping point. They're a foundation for further inquiry. Abductive reasoning therefore provides a starting point for further investigation. The hypotheses that are generated through abduction can be tested and refined through deductive and inductive reasoning processes. And identifying that starting point needs to be a flexible and adaptable process, and abductive reasoning absolutely gives us that foundation, which makes it suitable for a wide range of fields. You'll note throughout this talk I've repeatedly mentioned that this interaction is possible between the reasoning processes, and I think this is a really important take-home message that we should remember. We don't have to rely on one. Even within one project, we can start from one type of reasoning and progress through as we work towards the ideal processing of the evidence that is available to us.